If we have to rationalize a denominator that contains two terms, it is important that we use the conjugate of the denominator to ensure that any radical terms are eliminated through addition. Now, you probably saw in some of the lesson materials the definition for the conjugate, but the principle is really simple. We're going to use what we know about the logic of difference of squares, where opposite signs eliminated terms that had the same coefficient but were opposites of one another. We're going to do the same thing here. When we engage the conjugate, our multiplication is going to be the opposite operation of the denominator. So if the operation in the denominator was a plus, we'll switch it to a minus. If it was a minus, we'll switch it to a plus. And we're going to use that expression on both the numerator and the denominator. Now, the numerator is simple because the numerator has only one term in it. And if it had more than one term, we would just use the same logic of polynomial multiplication. But since this one has only one term, we're just going to distribute, and our new numerator is 5 root 6 minus 5 root 3. That numerator is just going to stay. Worst case scenario, you even just write the numerator as 5 times root 6 minus root 3, which isn't necessarily the end of the world, but typically it is done as a multiplication. Now, the denominator is where the interesting work happens. Root 6 gets multiplied by root 6, which makes a 6. Root 6 gets multiplied by root 3 with the minus sign, making minus root 18. And honestly, I am not concerned with that, with the fact that has a perfect square in it yet. I'm not going to need to go through any of that simplification. That's because the next multiplication, root 3 times root 6, is just going to give me the opposite of that. And that's what the conjugate allows us to create, is opposite terms with radicals that are going to simplify together. And then we finish that with root 3 times root 3, which just gives us a minus 3. Thank you to the minus sign that was in front of our extra factor right here. So minus 3. As was suggested, these two will knock each other out as being opposites, and we're just left with 6 minus 3, which is 3, and that's the denominator of our final answer. So while we created radicals in the numerator, we're not so concerned with that. We got the radicals out of the denominator. We're left with a whole number constant denominator, and that was because of the use of the conjugate, allowing us to get that sign change going so that we could see our work a little bit, see that elimination of those terms right here. Regardless of how complicated the multiplication is, the principle will remain the same. If we have that two-term denominator, we're going to use the conjugate. 2 root 7 minus 3 root 3, and then the same thing in the numerator. Very quickly, let's get the numerator out of the way. 2 root 5 times 2 root 7 will be 4 root 35. 2 root 5 times 3 root 3, 6 root 15. And if necessary, we'll come back to that later. We see a factor of a 2 here that's common here and here. Maybe that'll simplify with something with the denominator. We're not sure just yet. We're going to hold off on that, and we'll check any kind of simplifying at the end. Now let's check the denominator. We want to make sure we get that elimination of the terms. So 2 root 7 times 2 root 7. 4 root 49, which is just 28. 2 root 7 times 3 root 3 minus 6 root 21. 3 root 3 times 2 root 7 plus 6 root 21. Thank goodness, we're going to get our elimination of those radical terms in the middle. And then 3 root 3 times 3 root 3 minus 9 root 9, which is just 27. These two will knock each other out. We're left with 28 minus 27 for a very boring denominator of 1. Nothing else to simplify because of that denominator of 1, and there's our simplified form. No perfect squares in here, and no perfect squares in there. So the conjugate is our gateway to eliminating any kind of radical in a two-term denominator. if used appropriately, it should be able to eliminate if there are two radicals, or even if there is just the one radical. Because imagine if there was only one radical here, then this back multiplication is guaranteed to be a whole number. It won't change the work at all. Provided that you use the conjugate in both the numerator and the denominator, you guarantee the equivalence that is necessary in order to ensure that your simplified version and the original question are equivalent to one another.